Problem 3 is a calculus problem. So let's go on here. They give us a function, and they want us, and A just wants us to integrate that function squared. So let's just do what it says. So I'm going to do up here just to save space. So 1 to 2, f of x is x squared. They actually tell me that, so just plug that in. And then on top of that, they want you to square it. So this is a straightforward integration problem. So integral from 1 to 2 of x to the 4th dx. Now we got to integrate it. Right, and the way we integrate, we add 1 to the power and divide by our new power. So I'm gonna get x to the 5th over 5. Now again, this has limits, so I don't do a plus c. I do instead, I write the line down and I write my limits. Then I do top minus bottom. So I'm gonna plug the top number in minus the bottom number in. So 2 to the 5th over 5 minus 1 to the 5th over 5. 2 to the 5th is 32 minus 1 to the 5th, and I get 31 over 5. So that's it for A. Again, normally I do on the bottom, but I just want to save space for later. I didn't want to scroll up and down the whole time. So that's it for A. Now for B, the following diagram shows part of the graph of f. So here's the graph of f. The shaded region R is enclosed by the graph of f, and the x-axis on lines 1 and 2. Find the volume of the solid revolving around 360. So anytime you see this right there, you want to look at your formula sheet and write down the volume formula. So we're going to integrate pi from my limits of the function squared. That's just from the formula sheet right there. So in this case, if I plug my stuff in, I have a pi, my limits are 1 and 2. My function is the same function from above, x squared. Then I still got to square it, dx. If I simplify that a little bit, I get this, pi 1, 2 of x to the 4th dx. If you notice, that's the same thing we just did, classic IB. So I already know what this. I already know what all this is. That's 31 pi. That's 31 over 5, and then there's a pi on the outside. So I get 31 pi over 5. And that's the problem.